Welcome to the Clearline Group's e-learning session on improving forecasts with allocations in Hyperion Planning and Essbase. I would like to start with a brief introduction of myself and the Clearline Group. We'll then begin the presentation where we'll cover how allocations fit into forecasting, have a quick review of Hyperion tools and options for working on allocations, and then a sample of allocations within a real rolling forecast that I worked on. I'd like to begin by introducing myself. My name is Steve Light. I'm a director in Clearline's Hyperion practice. I've got about 17 years experience with Hyperion products. I started on Essbase 3 and I've been certified on every version of Essbase since version 4. I've also used Hyperion Planning, WA, and financial reports along with a number of other products. I'm a frequent speaker at different conventions and user groups, and I've also worked across a variety of different industries. The Clearline Group is a boutique consulting company based out of Chicago. It specializes in EPM. Our consultants have a long history of working with Oracle's Hyperion products, and most of them have worked together for well over 12 years. Many of our consultants are also certified on the various Hyperion products. Clearline provides its customers with a wide variety of services, ranging from initial assessments and roadmaps to full implementations and production support. We can also review and optimize existing applications or act as mentors to help improve your staff skills. I'm sure everyone knows basically what an allocation is. Most people consider it a system of dividing expenses and income among various branches and departments of a business. Most people who work on Hyperion allocations take this definition a little bit farther and break it into two broad types. The first type is when costs are allocated across the same level of a hierarchy. For example, an expense might be spread from one department to many departments, but all the departments are actually at the same level of the organization's hierarchy. This is often used with driver-based components in forecasts. The other common type is when you're allocating from a high level in a hierarchy down to its details. This is commonly used in a top-down or middle-out forecast to push high-level input values into the details of the plan. The first type of forecasting allocation that we're going to review is for a bottom-up plan, where the input starts at the level 0 and is aggregated up. The main thing that I would like to point out is that there are no allocations within the system, but that does not mean that the users are not using allocations. The users are forced to enter a large amount of data, and this can be very time-consuming and also prone to data entry errors. Most of the users actually enter all the data using some type of offline allocation process. They might end up just doing an even spread of their goal number down to the detailed numbers. This is going to further reduce the accuracy of their input. Some users might even enter a lump sum to speed up their process and to make their totals look right. But this can actually cause a lot of problems with calculations and reporting issues, especially if you're doing variances to other scenarios. Another option is to do a top-down forecast that starts with a single top-level number that is allocated down to the detailed levels. This can be a fast and simple process for the users to complete. They will have very little data entry, and it's a great way for them to plan if they have an assigned goal. There is a slight risk that the detailed levels may be slightly less accurate than desired if the allocation is poorly designed. This is normally not an issue if you have an experienced development team. This method is great when it fits your needs, but it can limit the user from planning at the level that makes the most sense for their business unit. The most flexible method is to use a middle-out forecast to start at any level that the business wants to use. This will also let you do a top-down or a bottom-up forecast if it's desired by the business. This is usually more accurate because the planners are only entering data at the level that it makes sense to them, and it's often faster because they're entering a lot less data. This is an example of a middle-out forecast where the user decided to start at level 3. It uses a waterfall allocation starting at that level and then fills in all the levels beneath it. The user can make adjustments to data at the current level that they're allocating from or at any of the lower levels. Some applications need to have zero-level calculations after the allocation. This is especially true if you have some type of unit conversion where the rates only make sense at the lowest level of detail. The last step is to complete an aggregation on your forecast to roll up all your numbers to create your grand totals. The next section of the presentation will review some options for completing allocations using Hyperion software. Oracle has provided a number of ways to allocate data within the Hyperion products, and there are also third-party tools that can enhance your ability to do allocations. The key is to pick the right tool for the job. Some options allow you to do upper-level writes, while others do not. There are also alternatives that provide better audit trails, and some options work better allocating across the level of a hierarchy instead of down it. You'll also find that some handle complex calculations better, while others work better on large data volumes. There are even options that allow you to work with calculations in memory instead of directly impacting the data within the cube. Hyperion Planning has 4 built-in features for completing allocations. The simplest one is adjusting and spreading data on a web form. You can change both individual numbers or multiple data cells by adjusting the values with either a percentage or a specific amount. Planning security will let the users only adjust cells that they have write access to, and the users are given an opportunity to evaluate the new values before sending them to the database. The next planning option is time-based spreading on a web form. This allows data to be entered at the upper levels of the time dimension and instantly allocated. It will spread data proportionally and can adjust for things like a 445 calendar and time balance members. This feature only lets users adjust the cells that they have write access to, and it still allows them to evaluate the data before sending it back to the database. The third planning option is the grid spread. It is a web form allocation method, but it also must be enabled in the data form properties. You can still allocate data by a specific amount or percentage, see immediate results on your data form, and save the data or discard it after reviewing it. But you also have selectable spreading patterns like proportional, even split, and fill. Mass allocation is the last of the built-in Hyperion planning allocation options. It is a little different than the first 3 that we've looked at. It must have the data form property enabled, and it also has to have a role assigned to it in shared services. The real difference in power behind mass allocation is that it can spread data even to cells that are not displayed on the form. It will allocate data to all the source cell's descendants, and it can even allocate across multiple dimensions. It does this with dynamically created calculation scripts. Mass allocation also has the ability to use custom-designed spreading patterns. You should also note that you do not need to have write access to the target data cells. This type of allocation cannot be undone since it's changing data directly inside of the cube. I have always been a big fan of Essbase aggregate storage. ASO has gotten even better in version 11.1.2 because Oracle has added an allocation option to it. This is a great option when it fits your needs. It will allow you to really scale up the size of your cube while still allowing you to run simple allocations really quickly. It can also allocate with an even spread or a percent of total. You will need to remember that ASO allocations are not quite as flexible as the BSO options. One of the main reasons is that you can only write back to the zero-level numbers inside of aggregate storage. Another Hyperion option is to use HPCM. This software allows you to do complex allocations with traceability maps, audit trails, data lineage, and user-defined business rules. It can do very complex calculations while still scaling, and the allocation engine supports a wide variety of methodologies. There are also some third-party tools that can help you complete allocations in Essbase. A&M's PACE product is a great example of one. It is a robust and easy-to-use in-memory engine that extends Essbase's spreading and allocation functionality with rapid calculation and advanced what-if modeling. The data is only written back to the Essbase cube when the planner decides that he is ready to send it. PACE includes additional features like built-in business logic along with multidimensional locking and spreading. Of course, you can also create your own allocations with Calc scripts, business rules, or in Calc Manager for either Essbase or Hyperion Planning. It's actually a lot easier than most people think. You can either create your own formulas, or you can use built-in functions like @allocate for a single dimension or @mdallocate to do allocations across multiple dimensions. The Essbase technical reference is a great place to start learning about functions like add-allocate. This is the actual entry for the add-allocate function inside of the tech ref, and it shows the syntax that you'll need to learn. It's probably not the most intuitive thing to read, so here's my attempt at making it a little bit clearer. The function is on the left-hand side. Everything else you see are parameters, with the optional parameters being in square brackets. The required parameters include the amount that you want to allocate, the allocation range, which is where you want to allocate to, the method, which is how the allocation works, and the basis member that provides the method or the pattern for the allocation. The optional parameters include additional information on how the method will work, along with a number of parameters to deal with rounding issues. So now let's try and plug in some business logic to the add-allocate function. We want to allocate the volume of the products to its children based on the current year's final plan, skipping both zeros and missing. The first thing we need to do is identify our parameters. The required ones are the amount, which is products, the allocation range, which are the children of the products, the basis member or pattern, which is based on the current year's final plan, and the method, which is spread. We are also using one optional parameter where we're going to skip both zero and missing values. Now all you have to do is plug your parameters into your formula and you're done. This is what it looks like. MD-allocate works essentially the same way as the allocate function. It just has a couple of extra parameters. You need to specify the number of dimensions you're going to be allocating to and their ranges. This section of the presentation will cover allocations in a real rolling forecast for a consumer products company. This company had multiple divisions that varied a lot in both function and size. They also needed to have a common corporate view of their volume forecasts. This application was built in Essbase block storage using System 9. It needed to be able to support forecasts with upper-level adjustments that could also be allocated. The system had about 20 planners and about 300 users. This application had 4 years of weekly volume data for over 30,000 products. The company also needed 5 versions for each of 15 scenarios, for a total of 75 combinations. The application was fully automated with error checking and email alerts. It also was able to do currency conversion and scaling on the fly, and had stored zero-level unit conversions. The best part was it was fast. Most of the calculations were done in just seconds, and company-wide allocations could be completed in just minutes. We were able to use transparent partitions to improve performance, but they also greatly simplified both the calculations and the security for the overall application. We also used waterfall allocations where each user could control the level of the hierarchy that they wanted to plan at. In other words, the user can pick a bottoms-up, top-down, or middle-out allocation for their portion of the forecast. They can also control the source and the percentage increase or decrease from the starting point for their forecast. The users have the ability to override any individual values generated by the allocation. This allows them to do a lot of what-if analysis, and they also can quickly restate all the products in the entire company's forecast. So how does all this work? In this case, we built everything using Hyperion business rules, and we used the Hyperion business rule launcher to gather the user input and to start calculations. The first step was to collect the information from the users and to run the setup calculation. The users are prompted for a source. This is the starting point for the plan. They'll pick the data that's going to be copied into it. It could be something like last year's actuals or the last month's final plan. Then they set the level of the product hierarchy they want to work at. This allows them to do a top-down, bottom-up, or middle-out allocation. The last thing they set is the percentage increase or decrease from the source. For example, they might want to do a 10% increase over last year's actuals. Now they're ready to launch their business rule. It's going to clear out the old forecast data, it's going to roll actuals into the historical periods, and it's going to populate the starting point for their forecast based on their input. We use business rules in this example, however it can still work with calc scripts. The only difference is going to be the runtime prompts that you're capturing in business rules are going to have to be loaded intersections to the database with calculations. You'd simply lock and send numbers like 1, 2, and 3 to pick the level that you wanted to work at or your source. You might want to consider doing this anyhow because the runtime prompts are in memory, and if you store the values actually in the database, you can come back at a later point in time and see what the end users picked. This is an example of the HBR launcher screen that the users would see. All they need to do is enter the information that's being asked for and then validate it. The validate button will make sure that they entered something acceptable, and they won't be able to launch the rule until it validates. This means they have to enter real member names and numeric values that are within the appropriate ranges. They'll be able to launch the rule as soon as the runtime prompts have been validated. Now they can look at their data, make adjustments, or they can even run an optional step to aggregate the database. They might want to roll up the product dimension before they run their allocation to see the impact of their adjustments on their grand total, or they might just want to do a high-level plan and not allocate anything at all. The next step is to actually do the allocation. It's going to do a waterfall allocation from the level that the user requested down to the lowest level of the product dimension. We were able to build in some additional intelligence into our allocation script. It's able to automatically switch between percent of total and even spreading based on the data patterns in the source for individual members. It's also able to identify discontinued products that are being maintained for history. It ignores them during the allocation process. After the allocation, the rule calculates some stored zero-level conversions. Then it's going to aggregate all the measures back up to the top of the product dimension. This diagram shows the forecast process and all the areas that the user can make adjustments or do what-ifs. The user starts the process and runs the setup where they pick the source, level, and percent change to populate their forecast. Now they're able to evaluate data, make adjustments, start over, or move on to the next step. Now the users will aggregate the product dimension. They'll have a second chance to evaluate the data, make more adjustments, or start over again. Once they get the numbers the way they like them, they can move forward in the process. Now they're ready to complete the allocation. After the allocation, they'll have a third chance to evaluate the data, make adjustments, or start over. When the user decides that they are done, they'll copy the results into the final version or into one of the what-if versions. As I said earlier, this is a fairly quick process. I've seen it completed in less than 10 minutes, which is pretty impressive when you consider that it took a few days before they started using this application. Now we'll take a look at the same process from the user's point of view. This user would like to create their October forecast based on a spring plan with a 10% increase, and they would also like to work at their forecast level 1, which is their P&L level. So they enter this information into the runtime prompts on the HBR launcher and run the rule to create their starting point. Only P&Ls 1 and 2 have data in the spring plan, so they're the only two that get brought over to the October forecast, but they do have the 10% increase applied to them. This user decided to make some manual adjustments to the P&L and entered some new data for P&Ls 3 and 4. They also reduced the value of P&L number 2. Now they've decided to run the allocation. The first step of this process is to identify the discontinued products so they can be ignored during the allocation. In this sample, SKUs 2, 18, and 19 are being maintained for history, but they're no longer being produced, so they should not have any data allocated to them. Now the allocation is ready to run. It uses a percent of total based on the spring plan for P&Ls number 1 and 2, but it switches to do an even spread for P&Ls number 3 and 4 since they don't have any data in the spring plan. Both of these methods skip the discontinued products. This is pretty easy to see in P&L number 4. It's completed the even spread on just 3 active SKUs instead of the 5 children. The last step in this process is to complete all the zero-level calculations and to roll up all the measures in the dimension to create all of your grand totals. You've probably already guessed that there's a little more going on here than a simple one-line allocation formula. To some extent you're right, but there are really only 4 allocation formulas in this part of the business rule. The rest of the rule is made up of some simple fixed statements and if statements, and there's also some substitution variables to avoid hard coding, along with the UDAs that we're using to identify the discontinued items. We tuned the rule to minimize the passes through the database and to reduce the block I/O. We could also schedule the process with default values for the runtime prompts. It was fairly easy to automate the UDA build so that we could identify the discontinued items, but we were also able to automate the substitution variables by building a relational database that could create and run the Maxell scripts on the fly based on the system date. Now we can fill in the parameters for our allocation, just like we did at the beginning of our presentation. The demo that you just saw wanted to allocate volume data from the current member of products to its children based on a spread member for the current year's final spring plan, It also needed to skip both the 0 and the missing values. The first thing we need to do is to identify the what, where, how, and pattern. This is actually pretty easy to do. The what is just the current number of products, the where is that member's children, the how is a spread, and the pattern is based on the current year's final plan. We also need to add an optional parameter for the skip missing and 0 values. The next thing we need to do is just plug in our information into our allocation formula. Now our allocation is basically done. Everything else that happened in the demo was controlled by if and fix statements. Here's a sample of the code that actually ran during the demo. It might not look like it at first glance, but it's actually pretty simple. The outer fix statement defines where the allocation is going to happen. The inner fix statement isolates the level of the allocation waterfall. The outer if statement checks the user input. If it's true, the allocation will run. If it's false, the allocation is skipped for this level of the waterfall. The middle if statement looks at the forecast source to see if there's data there. If there is data, then it's going to do a % of total allocation. If no data is found, then it's going to do an even spread. The final if statement checks to see if the open month is January. This is only required because it's a rolling forecast that has to adjust for the current year changing. You may not need this in your application. The last part of this calculation are the 4 allocation formulas. They're almost exactly the same, so if you can write one of them, you can write all of them. The first 2 are for the % of total, and the second 2 are for the even spread. The only real differences are the method, which is either share or spread, and the substitution variable for the year. You may only need to have 2 allocation formulas for your application if it doesn't cross multiple years. Please contact the Clearline group if you would like more information on allocations, Hyperion, or other EPM subjects.